Wells Fargo presents one of the surest ways to grow your money. A Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.
O'Reilly! It's Superstart Battery Month at O'Reilly Auto Parts. Get up to a $25 gift card after rebate with the purchase of select Superstart batteries. Our professional parts people will test your old battery for free and recommend the right battery for your vehicle. For power, performance, and reliability, choose Superstart batteries only at O'Reilly Auto Parts.
O'Reilly Auto Parts.
This is SpaceTime, Series 26, Episode 70, for broadcast on the 12th of June 2023. Coming up on SpaceTime, rewriting the textbooks on the mysteries of fast radio bursts. New insights show how the early universe quite literally crackled with bursts of star formation. And fresh claims the American government possesses intact and partially intact alien spacecraft. But where's the proof? All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers are raising new questions about mysterious deep space blasts of energy called fast radio bursts following the detection of an event which breaks the known rules about their origins. Fast radio bursts are ephemeral explosions, releasing as much energy in a nanosecond as the sun will produce in decades. They were first discovered in 2007 by the Parkes Radio Telescope in the central west of New South Wales. Astronomers like to study fast radio bursts and their host galaxies in great detail, not just to solve an intergalactic mystery about what they are, but also because they can tell us more about the structure and evolution of galaxies. And after years of research, scientists have begun to think they're getting a fairly good handle on these events. Originally, they were thought to be singular events, possibly caused by the catastrophic destruction of a star in a supernova. But later examples of repeating fast radio bursts sent scientists back to the drawing boards with new hypotheses involving exotic objects like black holes, neutron stars, and their highly magnetized counterparts, magnetars. The idea being that all fast radio bursts were repeaters, just with some repeating more often than others. The one thing they all had in common was their locations seemed to be in the spiral arms of distant galaxies. Galaxies which had been gravitationally perturbed by other galaxies, causing a high degree of turbulence within the gaseous arms, triggering lots of fresh starbirth. But these new findings, reported in the Astrophysical Journal, show a fast radio burst that appear to have originated in a much quieter galaxy, and that suggests a very different cause. The study's lead author, Marcin Glowacki, from the Curtin University node of the International Center for Radio Astronomy Research, says the new observations aren't showing the same turbulence which was detected in other galaxies known to host fast radio bursts. The discovery, therefore, clearly questions what scientists really know about these enigmatic events. The observations were carried out with the CSIRO's Australia Square Kilometre Array Pathfinder, or ASCAP radio telescope array in outback Western Australia. ASCAP is a synthesis array consisting of 36 12-metre parabolic dish antennas spread out in two dimensions with baselines up to 6 kilometres apart, located in the Murchison Observatory Zone, 800 kilometres north of Perth. Glowacki says while previous studies suggested that colliding galaxies could create massive stars that may eventually cause fast radio bursts, this paper's findings challenge that idea. The research simply hasn't seen the same clear signals of turbulence. Instead, he says the host galaxy appears to be undisturbed and quiet. Blavatsky says either the massive star that caused the fast radio burst was born another way, or that this powerful burst was created by something else entirely.
In previous studies where they've been able to localize the fast radio burst, find out what galaxy it comes from, and study the gas around that, they found the gas in the host galaxy to be very turbulent. And this suggests that this galaxy has recently been a merger of two other galaxies, and that would cause this turbulence, and this would start off star formation events, and that could lead to what would create one of the possible models for fast radio burst. In our case, however, the gas is not so turbulent. You could say it's quiet.
By having turbulent gas, you have more star formation taking place, and that means there's a greater chance of having stars that live for only a short period of time and then become neutron stars. Is that the way you're thinking?
Yes. More star formation means there's a higher chance of creating these really massive stars, and they have a much shorter lifetime. We're talking hundreds of millions of years rather than billions of years like our sun. And those stars will tend to give birth to the neutron stars, which are one of the progenitor models for a fast radio burst. So in our case, we don't see such turbulent gas. So that means that it's less likely to be the starburst activity that would create this massive star. Now, it doesn't mean that we can't create such massive stars in that environment, but it means they've either formed from another method, not from a galaxy merger, or there is actually something else that has created a fast radio burst.
Were you looking at a specific fast radio burst in order to do these observations?
FRB 211127. Basically, the numbers correspond to the date, so it was made in late 2021.
Where in the sky was it? How far away?
It's in another spiral galaxy, similar to our own Milky Way, and it's about 200 megaparsecs away, so many light years away. This was more luck, I suppose, that during the observations of gas of galaxies in that part of the sky, we happen to detect a fast radio burst. So we have two different surveys. One is Craft, which is looking for fast radio bursts, and the other is Wallaby, which is looking at the neutral hydrogen gas of galaxies, and we've worked together to make this discovery.
Has this turned out to be a repeating fast radio burst, or is this a singular event at this stage?
Singular event at this stage.
That's interesting, because one of the theories originally for fast radio bursts was that they could have been caused by cataclysmic events. It's a good explanation for something that gives as much power as the sun does in 10 years in just a nanosecond or a second or something like that. But then that was dismissed once we realized that some fast radio bursts were repeaters. They would happen over and over again. And that sort of ruled out the cataclysmic issue as a possibility. But what you found now, that left us with the option, maybe there are two different causes for fast radio bursts.
Yes, exactly. There may be two. There could even be more than that. And that's something that we'll just have to increase our sample size to get a better handle on.
What do you think's going on?
I feel like that there are two different populations of what causes a fast radio burst. That's due to things like we see different profiles for when we look at the profile of the fast radio burst from a repeater versus ones that are just one-off events. There does appear to be a distinct difference in the distribution, how long they last for example. So that suggests that there may be something different at play causing those two different kinds of fast radio bursts, the ones that repeat and ones that so far we've just seen one blip and that's it.
When we look at gamma ray bursts, of course, we know there are two different sources for those. The short period gamma ray bursts are caused by a different method to longer period gamma ray bursts.
Yes, that's correct.
How did you do your research?
So we're using ASCAP to do these simultaneous observations. How the Craft survey works, which is a survey looking for fast radio bursts, is ASCAP will do another survey. It will do its own thing. And whenever we monitor the data and see that there's a candidate for a fast radio burst, we tell ASCAP download voltages. 3 seconds worth. Just dump that and we process that data separately. Now that's key to being able to tell where the fast radio burst is because they happen on millisecond timescales. Normally you would not be able to tell what part of the sky it comes from. But using clever engineering and clever software pipelines to process the data, we can isolate the exact data that the fast radio burst happen in, and that allows us to determine where in the sky it actually came from.
That's Marcin Glavatsky from the Curtin University node of the International Centre for Radio Astronomy Research. And this is SpaceTime. Still to come, new insights show the early universe crackled with bursts of star formation. And a former US intelligence official claims the American government possesses both intact and partially intact alien spacecraft. But where's the proof? All that and more still to come on SpaceTime.
Wells Fargo presents one of the surest ways to grow your money. A Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.
Among the most fundamental questions in astronomy is how did the first stars and galaxies form? And NASA's James Webb Space Telescope is now providing new insights into this question. One of the largest programs in Webb's first year of science is the JWST Advanced Deep Extragalactic Survey, or JADES, which is devoting some 32 days of telescope time to uncover and characterize faint distant galaxies. Now, while this data is still coming in, we can say JADES has already discovered hundreds of galaxies that existed at a time when the universe was less than 600 million years old, raising questions about how galaxies could be so well formed so early in the history of the cosmos. Astronomers have also identified galaxies sparkling with a multitude of young hot stars. JADES will answer a lot of questions, like how did the earliest galaxies assemble themselves? How fast did they start forming stars? And why do some galaxies stop making stars? Ryan Ensley from the University of Texas at Austin is leading an investigation into galaxies that existed between 500 and 850 million years after the Big Bang. This was a critical time in the evolution of the universe, known as the Epoch of Reionization. See, for hundreds of millions of years after the Big Bang, the universe was filled with gaseous fog, making it opaque. However, by a billion years after the Big Bang, that fog had cleared, and the universe had become transparent, the way we see it today. The process which caused that is known as reionization. Scientists have debated whether active supermassive black holes or galaxies full of hot young stars were the primary cause of reionization. As part of the JADES program, Endersley and colleagues have been studying these galaxies with Webb's near-infrared spectrograph instrument to look for signatures of star formation. And they've found them in abundance. Endersley says almost every single galaxy they've looked at shows unusually strong emission line signatures indicating intense recent star formation. In fact, it would seem these early galaxies were all very good at creating hot, massive stars. And it's these bright, massive stars which pumped out torrents of ultraviolet radiation. That radiation transformed the surrounding gas from opaque to transparent by ionizing the hydrogen atoms by removing electrons from their nuclei. And since these early galaxies had such large populations of hot, massive stars, they may have been the main driver for ionization. The later reuniting of the electrons and their nuclei produces distinctively strong emission lines. Endersley and colleagues also found evidence that these young galaxies underwent periods of rapid star formation interspersed with quiet periods where fewer stars were formed. These fits and starts may have occurred as galaxies captured clumps of the gaseous raw material needed to form stars. Alternatively, since massive stars use up their fuel supplies very quickly and then explode, usually living for only a few million years at most, compared to the 12 billion year expected lifespan of our Sun, they may have injected energy into the surrounding environment periodically, preventing gas from condensing to form new stars. Another element of the JADES program involves the search for the very earliest galaxies that existed when the universe was less than 400 million years old. That's some 13.4 billion years ago. By studying these embryonic galaxies, astronomers can explore how star formation in the early years after the Big Bang was very different from what's seen in current times. The light from faraway galaxies is stretched to longer wavelengths and redder colours by the expansion of the universe. It's a phenomenon astronomers refer to as redshift. By measuring a galaxy's redshift, astronomers can learn how far away it is and therefore when it existed in the early cosmos. Before the Webb Space Telescope, there were only a dozen or so galaxies observed above a redshift of 8, a time when the universe was less than 650 million years old. But JADES has now uncovered nearly 1,000 of these extremely distant galaxies. The gold standard for determining redshift involves looking at a galaxy's spectra, which measures its brightness at a myriad of closely spaced wavelengths. But a good approximation can be determined by simply taking photos of a galaxy using filters that each cover a very narrow waveband of colours in order to get a handful of brightness measurements. Using this method, astronomers can determine estimates for the distances to many thousands of galaxies at once. Kevin Hainlin from the University of Arizona in Tucson and colleagues used Webb's near-infrared camera instrument to obtain these measurements known as photometric redshifts. And they've identified over 700 candidate galaxies that existed when the universe was between 370 and 650 million years old. The sheer number of these galaxies was far beyond the predictions from observations made before Webb's launch. The observatory's exquisite resolution and sensitivity are allowing astronomers to get a better view of these distant galaxies than ever before. Halen says that previously the earliest galaxies just looked like little smudges. And yet those smudges represent millions, even billions of stars at the beginning of the universe. Now, thanks to Webb, astronomers can see that some of these are actually extended objects with visible structure. And they can even see groupings of stars being born only a few 100 million years after the beginning of time. And that is pretty incredible. This is SpaceTime. Still to come, a former US intelligence official claims the American government possesses intact alien spacecraft. But where's the proof? And later in the Science Report, Australia's Bureau of Meteorology has issued a formal El Niño alert. All that and more still to come on SpaceTime. A former US intelligence official has claimed that the American government possesses intact and partially intact alien spacecraft. The official, David Grush, is an Air Force veteran and former member of the National Geospatial Intelligence Agency. The 36-year-old's gone public, telling Tucker Carlson on his Twitter show that he led analysis of unexplained anomalous phenomena, or UAPs, what we used to call UFOs, as part of the US Defense Department agency. Grush says information of these vehicles is being illegally withheld from Congress. He says that after turning over classified information about these vehicles to Congress, he suffered retaliation from government officials. He left the government in April after a 14-year career in US intelligence. Grush says the US government defense contractors have been recovering fragments of non-human spacecraft and in some cases entire spacecraft for decades. He says analyses of the material the spacecraft are made from has confirmed they're of exotic origin, meaning non-human intelligence, whether extraterrestrial or unknown origin, based on the structure of the materials used. Problem is, he's provided no actual evidence to support his claims. There are no photographs, no spectral analyses, and no sample materials. In October last year, NASA introduced a 16-member panel of experts from different scientific fields to head up a major study of unexplained anomalous phenomena. The space agency was tasked with undertaking the independent study following the reactions stemming from the 2021 report issued by the Pentagon's Office of the Director of National Intelligence. That report was able to categorize 163 UAP events as balloons, another 26 as drones, and 6 others as either birds, weather events, or airborne debris, like plastic bags blowing in the wind. But that still left 143 other reports received since 2004 that do not have an explanation. Now, not having an explanation does not mean they're UFOs from another planet. It simply means there's not enough information to be able to draw a conclusion. Last week, NASA held its first public meeting of unexplained anomalous phenomena. The 4-hour information-gathering event covered a wide range of topics and questions and was live-streamed online. NASA defines UAPs as observations of events in the sky that can't be identified as aircraft or other known natural phenomena from a scientific perspective. The new claims by Grush echo those of Bob Lazar, who in 1989 claimed that he had worked at Area 51 Sector 4, which he said was located underground inside the Papoose Range near Papoose Lake. Lazar claimed that he was contracted to work with alien spacecraft that the government had in its possession. Similarly, the 1996 documentary Dreamland included an interview with a 71-year-old mechanical engineer who also claimed to be a former employee at Area 51 during the 1950s. His claims included that he had worked on a flying disc simulator, which had been based on a disc originating from a crashed extraterrestrial spacecraft which had been used to train pilots. He also claimed to have worked with an actual real-life extraterrestrial alien named J-Rod, who he described as a telepathic translator. Whether any of this is real or not, I'll leave that up to you. This is SpaceTime.
Hello, saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
And time now to take a brief look at some of the other stories making news in science this week with the Science Report. Australia's Bureau of Meteorology has moved from an El Niño watch to an El Niño alert, meaning that while the El Niño Southern Oscillation, or ENSO, is currently still neutral, there's now a 70% chance of El Niño forming within the next few months. El Niños occur when the eastern tropical Pacific Ocean waters warm and the Pacific waters near Australia are cooler than average. And these conditions have now developed, but the pattern needs to persist for several more weeks before an El Niño can be declared. The Bureau says oceanic ENSO indicators have warmed to El Niño thresholds. Models are forecasting that further warming is likely, with ocean temperatures expected to persist above El Niño thresholds in the central and eastern Pacific until at least November. El Niños occur on average every 3 to 5 years, resulting in drier and warmer than usual weather patterns across the southern two-thirds of eastern Australia. The reduced rainfall in the east and the warmer temperatures in the south also mean an increased risk for bushfires. The cycle of El Niño and La Niña work as a sort of pendulum. La Niña occurs when water temperatures in the eastern tropical Pacific are cooler than average, and the trade winds, the planet's prevailing east-west winds, strengthen, creating warmer than usual water temperatures along the Australian Pacific coast, bringing heavy rainfall and increased flooding. The term El Niño was first coined by Peruvian fishermen who noticed their anchovy catches would decline when waters in the eastern Pacific were warmer than usual. This would normally happen around Christmas, traditionally celebrated as the time of the birth of Christ, and so the term little boy or El Niño was coined. And so the opposite, La Niña, translates in Spanish to little girl. If the forecasts are correct, it'll be the first time in 8 years that an El Niño event has been experienced in Australia. The last one brought severe drought, incredible bushfires, and general hardship for rural areas. Researchers have discovered that viruses such as SARS-CoV-2 can cause brain cells to fuse, initiating malfunctions that can lead to chronic neurological symptoms. SARS-CoV-2, the virus which causes COVID-19, has been detected in the brains of people with long COVID months after their initial infection. The findings, reported in the journal Science Advances, are based on research undertaken at the Queensland Brain Institute, exploring how viruses like COVID-19 alter the function of the central nervous system. Almost 7 million people have now been killed by the COVID-19 coronavirus since it was first detected near China's Wuhan Institute of Virology around September 2019. The World Health Organization estimates the true death toll is likely to be around 18 million, with some 768 million confirmed cases globally, almost 10% of the world's population. A new study has found that well over 60 billion invertebrate animals were killed in Australia's 2019-2020 Black Summer bushfires. The findings, reported in the journal Australecology, were made in a study conducted by La Trobe University, revealing the alarming loss of invertebrates in the Australian temperate rainforests following the catastrophic fires. The fires also killed well over 3 billion terrestrial vertebrate animals, including many highly endangered species, some of whom were driven to extinction. The Black Summer bushfires burnt out over 186,000 square kilometres of forests. It also destroyed some 6,000 buildings, including 2,779 homes, and killed at least 34 people. Smoke from the fires crossed the Pacific Ocean, affecting New Zealand, Chile, and Argentina. A strange anomaly which has had people baffled for years is the apparent ability of some people to make streetlights turn off as they get near them, and then turn on again once they've passed by. It's known as streetlight interference phenomenon. Tim Mendham from Australian Skeptics says that apparently this is something that thousands of people can do, although it's never actually been scientifically tested.
This really weird little theory that people can turn streetlights on and off just by thinking about them, by approaching them, and then when they move on, the streetlights
like in Mr. Bean. He walks past a TV store. As he walks past, the TVs all go static, and then as soon as he walks away, they go back to normal.
There's this particular thing, a phenomenon called, very cleverly thought out, streetlight interference phenomenon. So it's an SLI does. The people who can do it, a SLI do. Nothing to do with hamburgers. It's also called high voltage syndrome, which could have something to do with AC/DC. The thing is, it's never been properly tested. It's one of those things which might be an interesting coincidence that you notice it when it happens, you don't notice it when it doesn't happen. Maybe that means the power is only intermittent, or maybe it's just luck. There's various explanations put for it, and mainly, I think the main one is that you do notice it when it happens, you don't notice it when it doesn't happen.
So it's positive reinforcement.
Positive reinforcement, yeah. So it's a curiosity. They say it's been happening since the 1800s, ever since there's been streetlight. Fair enough, if it is streetlight interference. So
it worked with gas lighting as well as electric lighting.
I don't know. They say it did, but that's a more interesting thing. You're not going to get
different systems.
I know. But that's beside the point. It is a weird little novelty thing. It was actually first commented on by a fellow named Hilary Evans, who's a collector of miscellanea and weird stuff. He and his sister, I think it was, developed a famous library, called the Mary Evans Library. You find a lot of old photos and drawings and that sort of stuff. They collected all this sort of stuff, so everything old, really. But yeah, he was very interested in the paranormal and therefore collected a lot of stuff about this. So he was the one who gave it the name high voltage syndrome. It's a funny little thing, and it's cute. It's not much more than that.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.